workshops. She's taught women how to code with Go, me included, actually, believe it or not. Not that I'm very good, not like you guys. But she has been a hero in my eyes. She is a Lismore resident, and she's managed to rescue 9 lives on her handful of paddleboards with her Jack Russell dog, who has a life jacket. And it really is a serious thing in my eyes, and I really would like to thank you very much for raising nearly $600 for the donations towards the people in Lismore. And she has told us that this particular organisation have been amazing in what they do, working from the ground up and coming together as a community, and actually, resurrecting the damage that's happened. It's still going on. Sorry, I don't want to go on, but it is something that is going on, because it's not just the flood, it's the landslides. There's people who are trapped outside of Lismore, and villages can't get in or out for the next year. Helicopters have to get the food down, and there's only the funds raised to actually cover the cost of that. And thank you very much for your contributions tonight for that.
Now, you will note that there is a GoFundMe. I will leave that link on my laptop as a QR code. You feel free to keep donating throughout the night. And amongst the other changes that we have is that we've decided to add Tiffany at the back over there.
Hi,
everyone. To our roster of organizers, because we are getting quite busy. Surprises for next year maybe, or end of this year, who knows? May have a con. Anyways, our schedule for tonight, we'll start with Dave, who will be talking about generics, and then we'll have a break. More mingling, more food and stuff. Talking, essentially, mingling is the thing, right? And then we'll follow up with Corey's talk, and that's the night. Next month, we have another meetup. Wow. It's as if we're back properly. So our next meetup is on the last Thursday of June, 30th, and right here. Same time, all right? Without further ado, let's invite Dave and to give his talk. That's your cable over there.
Oh, sweet.
I think that's the USB-C.
Yep. I'm going to use HDMI like a pleb.
All right. Cool. I've seen those videos.
My laptop has one of those. Is this thing working? Yes. Cool. All right. There it is. Cool. Hi everyone, I'm Dave. You might have noticed on the event it said Josh Wales was doing this presentation. Apparently he's my brother, but the truth is I just pretend to be 2 people at once to trick my boss into paying me twice. So don't tell anyone.
Are you tunes?
No, we're not, actually. It won't work. In truth, Josh prepared this presentation. I'm just doing it for him because he couldn't make it in, so I have read it before, don't worry. But I'm going to do my best to present his talk for him. So yeah, it's on generics, the new feature in Go 118. You might have had a look at it, you might not. We're going to go from the start. So we've got, in generics, we've got generic types, and we've got generic functions and constraints, and we have type approximation. So we'll go through all 4 of those. So generic types allow us to declare 1 or more type params, where these params can be used to define the type of an argument slice map, another generic type. We can now avoid code duplication. It's worth noting that you're not actually avoiding code duplication, you just can't see it. When you create a generic function, Go is duplicating your code for you, which I'll explain a little bit later on. And it largely, but not entirely, replaces the need for the interface notation. In fact, they've created an alias for that called any. So you can now use this any keyword instead of interface. So a good example is you can have a generic paginated list with a collection of a type. So then you could create paginated results, which are strings, and then populate it with strings, and you could do that with any type. So that's, you only have to define that struct once in your code, and then you can use it for any type. So you've then defined the behavior of a paginated collection just once. When this is compiled, the compiler will actually look for every use of this and which types you've used and actually duplicate it for each type you've used. So the resulting code isn't any different to where if you had just duplicated the code. It's just a bit neater when you're reading the code. So it's purely a convenience and it has no actual function once the code's running, which is good, by the way. We're not losing performance for this, we're just losing compilation time. So generic parameters, we can define a function and then define a generic parameter t with a constraint any, and then we can put this t as our parameter type. So then this function can take a list of anything that fulfills the t constraint, which is any. So it can take any type. And then the return type is the same type as the input type. So this function creates a copy of the array, and the array can be any type you want. So it just does a loop through the array and creates a new array, appends them together and returns it. So you can have a list of strings or a list of ints and call this same copy function on both, and it will work. Any number of params can be set. You can just name them anything. The convention is single character uppercase though, but you could name this literally anything you want. It just wouldn't be very readable if you didn't do it like that. So this one is a map function, which you might have used in JavaScript at some point. You can now do that in Go without writing one for every type. So here you've got a function that takes the same type as the items and then outputs a new type, which is the type of the result of the map. So you can see it creates a new array, runs through our input array, and then creates the new array by running the elements of the original array through the function you've provided. So you're mapping the input array through that function. Yeah. So you can actually make use of type inference as well. So if we use this map, passing in the int to string function, and that's a function that takes ints and returns strings and just converts the int into a string, pretty simple. The map, if you call map with that function, then it infers that the resulting type is strings. So you don't have to make a var of type string. You get all the same convenience you always do in Go with inference. There's one big limitation. You can't create a method that is generic. You can only create a non-receiver function that is generic. So you can't create like object-oriented stuff, but use generics. And I believe the reason for that is that it makes the compilation unbelievably complicated or impossible, I think is the words I heard.
It's the expression problem. It's what Phil Wadler calls the expression problem.
Okay.
Yeah, go on.
Yes, you can. Someone come and ask Chu that question later. So generic constraints. So instead of using any, we can actually constrain the generic function to be more specific, and this allows us to use more operators on the types that come in. For example, you can, instead of saying any, say comparable, and then you can use the double equals comparison operator in your function. And then ordered, you can use greater than, less than, etc. So these allow you to do operations with the things coming in. Whereas if you do any, you can't use operators because not everything can be compared or greater than, less than, etc. So a good example of where you'd use that would be sorting something. So you could create a generic sort function that can take a list of any orderable type which would be like any number, effectively, or a string, because strings can be alphabetical, or any derived type, anything that has the ability to be greater than or less than something else. So that you put that constraint there, that constrains that type to ordered, and then we just do a sort slice with a sort function. Yeah, that's pretty handy. You can actually write your own constraints as an interface. In fact, you can use an interface as a constraint that you would otherwise have. You could also just pass in the parameter as an interface. This is a little bit of a useless example. That's cool. And you can define a custom constraint as multiple types. So you can say a decimal is either a float 32 or a float 64. And then the generic function can do anything that both of those can do, effectively. Or an integer can be 64 or 32. So as long as the operations you do on the integer can be done to either of those types, then it's allowed. And then there's type approximation. So this little tilde, I believe it's called, it means that it's this type and any derived type. So if you've got an integer type that's derived from int, then it will fulfill that int, and also fulfill integer. So any derived types can be passed into your generic function. They don't have to be the primitive. So here's an example of a function that's taking a number, which is either a float or an integer, whereas a float is a float 32 or 64, and an integer is an int 32 or int 64 or any other int. So all of those things can use the plus equals operator, so they can all be used in this function. So you could pass in a list of any one of those types, you'll get the sum. So more examples. So we can actually go to VS Code, and I've got some examples we can run. So here, we've got a filter function. So here it's a list of anything, and then a function that takes that type and returns a bool. And then we're going to filter the list based on whether that bool returns true or false. So we go for every item, if the function returns true, and we append it onto the result. And then we have another one that is unique, that's going to filter the list by unique items by using a map. So every time we see a new item, we're going to write it to the map, and then when the OK returns true, we don't add it again. So we're going to filter the list down to the unique items, and that can be any comparable type, because to see that it's unique, it needs to be comparable. So then we have this isInt function we're going to pass into our filter. So we can get this list of strings, call unique on it, get all the unique strings, call filter on it, get only the ones that are ints, can be converted to an int. So we can run that one. Why can't I type? There we go. So we got all the strings, and then we got the unique strings, so it got rid of the extra 1, 2, 3, 4, 5, and then we got the only ones that are only ints. There you go, that works. This one is a filter with a map. So that shows our enter keys function. So we've got two different types, the key and the value of the map. And then this one is keys, so it's giving us a list of all the keys in the map. So you can pass in any map of any type and get the list of the keys, which is quite useful. And then a filter function for a map, where the function takes both the key and the value, and then filters. So if we've got a map like that, we could get all the keys like that, just with keys. We could pass in a filter function that returns when value is greater than 2, and get the values greater than 2 filtered. We could filter out 3s, so only return true when it's not 3 or the number 3. And then we could filter by a regex, for example. So there we go. So we've got all the values greater than 2, we've got everything but 3s, and then we've got the ones with the value, with the keys are alphanumeric, or alpha, not numeric. That is wrong. Cool. So this one's the sum example, and then there's a max example. So the sum was in the presentation. The max, any ordered type, and then this is using a ellipse. Can't remember what that's called. Can someone remind me what this is called? Yeah, that one. Yep. Yes, so this is going to find the max value of any type that is ordered. So the ordered allows greater than. And this is going to come back with a whole lot of results. So here's our ints, and we've got floats. So these are both ordered types. They fulfill the constraint. We can sum the ints, or we can sum the floats with the same sum, or we can sum a new array. And here we're actually defining what type. So here, if you want to define the input in line like that, you can define the type with these brackets. So usually we're using type inference by just putting a predetermined type in, but here we can put in numbers and tell it what type to pass them in as. So that could be float 64 as well or something. And then max of the ints, max of the floats, max of those two things, max of the words, they all work, same function. Yep. So we've got the sum of the ints is 15, we've got the sum of the floats is 3.39, sum of those 6.3, then the max is the highest int is 5, the highest float was 5.2, the highest one of those is 3.8, yep, and the last one in the alphabet here is pair, so that's all good. Now we can look at a sort function. So here we're going to use the ordered constraint because we want to use the less than comparator. I just typed something I didn't. So here is a generic sort ordered with any type of list. So we can just get a string list, an int list, a float list, and just call sort ordered on any of them, and it will sort them. And we only had to write one function. So this is probably my favorite one. The one that I most likely actually use. So yeah, sort all of those things. And there you go, they're all sorted. And then here we can do a sort and then actually pass in a less function. And then the function has the parameters of two different t's, obviously, so it's like that. So we've got a person, and then we're going to have two different less functions, by, oh gosh, whoopsie, by age and by name. So here we've got people. We can sort people by age, or we can sort people by name. It's super simple like that. So. Boom. So the first one is sorted by age, the next one they're sorted by name. And that is just about it. Generics.
Questions? Anyone? Anyone have questions? Yeah. Anyone have questions? No? Oh, okay.
One question. What's the error message when we have compounding error?
What's
like? more like when we program in C++, use template stuff, we could get very weird error message that we cannot understand. So yeah. So what's the error message for Go generic? If we have any like type mismatch or interface mismatch?
You'd get a compilation error. I couldn't tell you what it is, but off the top of my head, you'd probably go try it out.
Constraints help with that because, well, I don't know, in C++, yeah, it doesn't, it just tries to compile it, and if you don't have the operators, then you get all these huge errors. But constraints in Go make it much nicer.
Contracts in C++? Okay, so in C++, if you have contracts, it's very similar to the way constraint. So, sorry, concepts. Yeah, yeah, concepts. Not yeah. You know, yeah, exactly. I've not coded in C++ for 3 years. So last time I coded in C++. Anyway, so yeah. Any other questions? One? No? I've got one. Have you used generics at work?
I have once.
Oh, what is it for?
We did a per field encryption and decryption library. So we used tagging on the fields on a struct.
Yep.
And then just had a generic encrypt and decrypt function that you could pass any type in. That actually used reflection. So it wasn't like a pure generic function.
Okay, yep. Okay,
Yes,
that makes sense.
That's the only time I've used it, to be honest.
Same use case actually for like Gogonia. We're moving to generics as well, and a lot of the things that we do requires reflection anyway. So,
Yep.
Anyone else? Yep. Okay, so you and then you.
What's the state of the language server, Go please, in terms of auto completion of say functions within a generic call?
Gosh, I couldn't tell you. I haven't used it enough to tell you, but I'd say probably not great, judging by how they've caught up in the past with new features.
What he said.
It took a while for modules to work in any editor. So I'd say about the same.
Okay. Who were you? Yes.
Hi, my name is Nguyen. I'm not Golang developer, but I still have a question though. Why it took so long for Golang to have a generic type?
Wow. It's almost like you're asking for my opinion.
I'm not trying to be a black sheep, or just
Have a look at Ian Lance Taylor's GitHub posts. He spent like 8 years just going, here's a proposal, here's what's wrong, here's a proposal.
Yeah.
Have a look at the GitHub tracker. Ian Lance Taylor's posted many proposals for generics over the years, and each one of them has significant flaws. So the first time they thought they might have it was contracts, and then they went and talked to Phil Wadler and like, actually no, we're convinced to do it just with interfaces and this new approach. And so it was just a matter of them getting something that they felt didn't complicate the language too much. But they've been working on it in the background for a long time.
And if you've ever worked on writing your own programming language and you don't use a Hindley-Milner type system, you have no idea of type variables and stuff like that. If anything I just said just went over your head, you're going to have a hard time implementing any kind of programming language with generics because you either complicate the compiler, name mangling from C++ comes to mind, like the errors that he mentioned earlier. With name mangling, you will have all sorts of errors that you will not be able to understand. So that's the cost of your compiler. Or you have, like in dynamic languages, where you have unit type. Again, if you're a subscriber to like Bob's theory, what's his name? I can't remember his last name, but point is, if you're a subscriber to the unit type theory, then you understand that having a dynamically generic or type erasing kind of generics would impose a runtime cost. So they're all different considerations that you have to take into account before you actually can implement a very good generics system. And Go is, I think, one step on the way there. So, yeah. Sorry.
That's okay.
I have a lot of thoughts on generics. I wrote a lot on Go's generics.
Hi, Dave. It's Darren.
Hi, Darren.
it's been a while, and we've finally got generics. Do you think it'll take off in the language? Bit of a hypothetical, but
I think it will in very, very specific places.
okay.
I would love for. I don't really want it to be everywhere. That would be my answer.
So not used for pollution.
Don't use it for the sake of using it, basically.
Yes, fair. Because I noticed with you seem to favour the sorting section of your presentation over the rest. So
Yeah. I think you could save lots of messy duplication in some cases with that, so it's worth it. But there's lots of places where it's probably not worth it. It's probably easier just to do it the way you've been doing it, unless the way you've been doing it is giving you the shits. Just keep doing what you're doing. That's what I reckon.
Thank you.
Have you tried any generic channels? Because I think
No, I haven't actually.
channels and generics is an interesting intersection where probably, a lot of other languages have generics, but Go and it's pretty unique.
Channels are generic from day one.
But if the type you use in your channel is a generic type, then you can do all sorts of interesting things like filter and sort and all sorts of stuff. Anyway.
You could have more than one type in the channel at once. Is that possible?
No, I don't think so, because you have to instantiate each call.
It'd have to be a generic type.
You have to instantiate the channel with a type, wouldn't you? I need to
It's
try
something
that
I
now.
looked at,
You've
but
piqued my
I
interest.
haven't had time to explore myself.
Yeah.
But I thought it would be one of the really interesting areas to explore in Go.
I think generic channels would be very good if you export that type, and then some other type can implement the constraints that generic. Yeah. Sorry. Okay. So plan of action. We're going to mingle around like human beings. We're not going to take off our skin suits. Sorry. I think only I have them. So go mingle. We'll have 10 minutes, and then we'll have a next talk. Okay. Remember, act human.
I'm going to have to be, aren't I? Thank you. Thank you.
Okay, everybody, want to grab a seat, please. Exciting talk coming up on how to write a AAA game using Golang. I'm joking, of course, no pressure.
I'm not joking.
Oh, wait, I guess the talk.
I hope so. Yeah. I'm not EA.
If I could just ask everyone to please take their seats, if that's okay. Thank you very much. So sorry, we have overrun slightly with our mingling. I know it's been a long time, we've got a lot to catch up on, but we do have some time after this as well to catch up to. Thank you so much for taking your seats, everybody. I would just like to introduce you to Corey Rogers, who is here today to talk to us. He's from golang-syd, and he is going to talk to us about game development with Go and some really cool stuff that he's discovered with visualization with data as well with Go. If you have any questions, please feel free to ask Corey afterwards. A big round of applause, please, for Corey.
Is it on? Is it on? Yeah. All right. Yeah, cool. So a bit different to the last talk. This is a bit more of a journey piece for me. Very, very first talk that I've ever done, so please go easy on me. My name's Corey Rogers. I'm a full-stack engineer. I work for golang-syd. And this is a bit about me. So one of my passions is game development. I do it as a hobby. I find it kind of taking a break from coding, but not. I work in the counter-US space, so counter-drone technology. Passionate about UX and UI design, and so I love seeing things look cool on the screen. Love data visualization. Probably a strong word now looking back at it. It's a little bit tricky to get a handle with sometimes, but yeah, what the hell. I play piano and I've not got one but two cats. So a bit about golang-syd. This is not a plug, by the way. So golang-syd develop counter-drone technology products. We sell to the military, sell to prisons, we sell to big events like marathons and whatnot. And there's some of our products. So we've got the Drone Gun Tactical, our Patrol, and we sell a lot of sensors. So I'm not going to bore you with too much about that. Please do. Oh. You have to come and talk to me after. I'm happy to tell you what I can. And yeah, this is the main product that I work on. And this is the C2 command and control system. So essentially what we do, we fire radars and RF into the air. If there's any drones coming past, it detects them. We do some magic on our side, and I put the dot on the map. So yeah, I did this color. I did this color as well. I also added one of these buttons. So why am I talking about game dev? Why am I talking about game dev at a Golang Meetup where you probably want to know all the internal stuff, which I could probably not tell you about? So the reason I came to talk about game dev is, number one, like I said, it's my passion. And it basically bunches all my hobbies into one, and I've got a lot of hobbies. So it uses music. I get to program. Getting better at programming, make my job easier. And I like drawing as well. So all them things into one, and still haven't made a game. So what is Game Engine? I like this quote, taking it from a website, but I've credited them. In a nutshell, game engines work by laying the framework that allows the user to create something like a video game or digital twin more easily than if they had to make it from scratch. So I just want to talk a little bit about a digital twin. It's a really interesting use case because in the stuff that we do at golang-syd, and I mean, it's got a lot of applications in other businesses as well, which use IoT devices, is it just allows us to take some data from the real world and then operate on that data via a simulation, do models, calculate probabilities, statistics, and diagnostics as well. And it also allows you to do visualization, which is pretty cool. So back to game engines. The two biggies. Unity. So Grave Hobbyist, the one that I use, I think it's got a great tool chain. You can do 3D, you can do 2D. plethora of documentation everywhere, tons of tutorials. So you can see Cuphead, City Skylines, two of the big ones that have been made in Unity, and Unreal Engine. AAA game quality, super high fidelity light rendering. It's one of the industry standards for game development these days, but it's mainly 3D focused. So why did I choose a game library? And why did I choose Pixel? So Pixel is one of the most user-friendly Golang game libraries that I think is about at the minute. It's pretty similar to Raylib if anyone's used that in the past, but I've used Raylib using C++. And I really wanted to know how game engines work behind the hood rather than being abstracted behind kind of a more, I don't know, user-friendly engine. So again, why? Pixel, you can mess around with shaders, you can create great platformers like that one. And you can also do some interesting stuff with raycasting as well. So it's not entirely 3D, but it tickles that niche. So I'm not going to go through all these, but essentially it's got all the ingredients you need to create a game, essentially. So you've got audio, you can draw text in it, it's got batch drawing. You can use it on Windows, Linux, and Mac, which I think was pretty cool. And it's tons less bloat with features that the bare minimum, essentially. So the game loop, so this is the main thing that, again, I want to learn a little bit more about. And the game loop is essentially process and input. If you press the A button on your controller, you're going to jump. The update loop, which runs every single frame, and this manages basically where you see a square move on the screen, whether it's up, down, left, right. And then the render stage, so that's essentially just seeing what you've put into your program on the screen. So these are just some small little snippets on literally how easy it is to get started with it. Essentially, you just define that you want to create a new sprite using the Pixel library. You push an image into the sprite method, and then it runs through the loop and draws it on the screen. So you get something like this. And you can see that it's in the bottom left corner. And the next part I wanted to show is how easy it is to move to the middle. So you just pass in window.bounds.center, Pixel does its magic, and it moves it into the center for you. That's about it for the code. So to summarize, really, the pros of Pixel, I think I've already touched on this as well. It's lower level than Unity and Unreal. Gave me a lot better understanding of how Golang manages these sort of things, as opposed to stuff like JavaScript and C++. Being a game library, you can visually see your progress instead of, I don't know, not really, how do I word it? I think it's easier to find bugs when you're doing more visual stuff. I'd say it's fairly simple to pick up, and it's a lot less bloated. And some of the cons, realistically, it's limited to 2D games. Very limited documentation, even though it says it's got great documentation. And yes, it's a lot less user-friendly than typical other engines. And these are my main takeaways. So one of the big things that I noticed is after playing around with very low-level game engines is that I felt like I got better at debugging. Now, I do a lot of front-end work. I'm a full-stack developer, but I do focus mainly on the front end. And I noticed when I was debugging like render methods or how many times something draws on the screen, I noticed that, I don't know, little things came as second nature to me. Second is I've wanted to get better at vector mathematics in a while, pretty nerdy, but that allowed me to do it. Working in the game engine, there's a lot of vector mathematics you need to calculate. I know how far something is from you, how fast you need to move towards it and whatnot. In a long time, one of the best learning experiences I've had. And yeah, I don't really spend that much time doing anything else other than playing around in game dev stuff, but doing it in a lower level language like Golang was definitely an experience. And the last one is I'm going to be sticking to Unity for now. It's just a bit too, I don't know. I like to spend time getting my ideas onto the screen, and it can be a bit of a barrier when you're working with Golang, especially, to do that. And that is me. Any questions?
We'll start at the back.
Have you tried to cross-compile it as a WebAssembly module and load it in a web browser?
No, but I'm definitely aware of that. The language that I did want to, again, play around with is Rust. I think it's got better bindings to compile to WebAssembly. But yeah, never tried it, but that's definitely something on the list to do. Yeah.
Have you tried Abby10?
Yes, I have. I actually, when I first told Katie that I was coming to do this, I was like, yeah, I'm gonna do it in Abby10. And then I spent maybe half a day with it and decided that I was going to throw it out. I don't know, maybe it was documentation I couldn't read properly. Who knows?
So I was actually going to ask you to break down why you ended up choosing with Pixel instead of Abby10.
Yeah, simply documentation. Yeah.
Yeah. Okay. Cool. And the Abby10 documentation is.
I'd say it was all right. I think in terms of tutorial-wise, I probably needed something a little bit more straightforward, and Pixel's documentation was a lot more straightforward. I don't know whether it's because the guy who wrote it kind of literally started from very, very basics and told me everything that each part's doing. But yeah, I find it just easier to work with.
Cool. Anyone has any question? Yeah, sorry.
Did you bring a demo of your game?
No. I could have shown you how far I got, but it was very broken, so I didn't want to embarrass myself. Huh?
Yeah, please do show.
I don't have it. I don't.
Okay, it's okay if you don't have it.
There's a question at the back here. I'll just go over.
Hi, yes. I'm just wondering, I really like to play a Xbox game called Ori. I don't know whether you're familiar with the game. I'm just wondering, with this Pixel engine, will I be able to create a game like Ori?
Realistically, I'd say no unless you've got 12 years. No, but seriously, nah. If you want to create something like that, I actually think Ori was created in Unity, to be honest.
In Unity, okay.
Yeah. I think the main reasons is just the rendering and the light pipelines in Unity to get those visual effects and you know what I mean, the fluid controllers and stuff. It's all been done for you in Unity, so you can really focus on the art and visual style. So yeah, I would not, especially in this state, I would not recommend using Pixel for anything like that. But if you want to learn the internals, you want to deep dive into, I don't know, how things move across the screen, or even just graphics programming, if you're half interested in that, I think is a really good place to start.
So where is a very good place to start? Pixel?
If you're generally just interested in graphics programming, I don't know how things work behind the hood, I'd say it's a pretty good place to start, especially if you're versed with using Golang. If you're not, there's Raylib. I mean, you've got Golang bindings for Raylib, but I found they weren't as good. But yeah, if you know C++, again, Raylib's another great place to start as well.
Thank you.
Thank you.
Just a quick question, sort of to tie into the previous talk, is you know a lot about vector graphics. What about a generic vector graphics library for Go?
I use TypeScript, so that's where my generics come in. In terms of generics, with the stuff we're using, we built all of our backend in Golang, and our engineers who are more focused on Golang are trying to use generics, but after the talk, maybe there is specific use cases which, again, I would have no place in talking about. So.
Cool. Sorry. I was actually looking at my examples of Pixel and Abby10. Sorry. If anyone wants to look at an Abby10 example, I have some live here, but I don't actually have my Pixel on this computer. Or in GitHub. That's strange. Anyways, any other questions?
Could Pixel be a substitute for a dynamic SVG library in Go? Because I can't find one.
Good question. The thing is about Pixel, so you can actually draw primitives with it, and it's got a very good helper library called Pixel IM, When you're drawing SVGs, essentially when you draw your polygons by putting in your XY coordinates and whatnot and drawing your paths, it's got a very, very similar system. So I think depending on your use case, you could certainly use it. I've even thought about using it in kind of a work, using it for work. So when we detect drones and stuff, one of the things that we really need is kind of like a game simulator, literally. So you could click different paths on like an overview map, and then I don't know, you create a flight path, really. And I've kind of toyed with maybe experimenting with something like that, but yeah, unfortunately, I couldn't give you any more information.
Translating MIDI data.
Okay, yeah. MIDI, do you say?
Yeah.
Yeah. For what use case?
Music applications.
Ah, wicked. What like Ableton and stuff like that? Or?
Well, taking data out of a synthesizer.
Yep.
And then displaying it visually.
Oh.
I've done it with JavaScript.
Yeah, it's a lot
vanilla
slower.
JavaScript.
Yeah.
I'd like to do it in Go.
Yeah. You get like much faster frame rates if you pump in a lot of data in there.
Yeah.
Interesting.
Cool.
Any last final questions?
No?
Okay, well, thank you so much, Corey, for your talk. Thank you very much.
You.
So if anybody would like to join us afterwards, we are probably going to find somewhere to catch up after the feels like forever years, however many it is, to catch up. So anyone who would like to join us, please hang around. And anyone else, then hopefully see you next time on the 30th of June.
And
right here.
we're nice people, so trash in the bin, please. Thank you.
Yeah, thank you. Thank you so much. Enjoy your evening.